Let's discuss question number 5 from test 1, test 2, sorry, test 2. So let's read the question. A disk of mass m and radius r has a concentric hole of radius small r. Its mass moment of inertia about an axis through its center perpendicular to its plane. So this is from engineering mechanics, basically the dynamics part. Okay, so what is asked? A disk of mass m, it's a hollow disk, so you have capital R, and then you have a small cutout from it, which is basically small r. Okay, so you have only material in this r minus smaller region. Okay, and you are supposed to find out the mass moment of inertia about an axis passing through its center and perpendicular to the plane. Okay, so before this we need to just, because we need to know what is the mass moment of inertia of a disk about its center. Now mass moment of inertia about its center, what an axis passing through its center for a solid disk and about its center perpendicular to its plane is basically m capital R square by 2. So this is what is the mass moment of inertia. Okay, now we have here basically, so this is on the solid disk is of mass m, this is the mass moment of inertia about its axis of mr square. Okay, so now this is our problem. On this can be looked as a solid disk minus a small disk or small r. Now this is mass m1, this is mass m2, and this is of mass m. Okay, so now m is given mass square. So the composite disk, I can visualize it as composite disk of r minus a smaller thickness. I mean thickness is uniform, but the radial is r minus r. Can be looked upon as a solid disk of capital R, your minus a solid. So basically we are removing a material of a material equivalent to a solid disk of radius r. So how do I now analyze? Now I know, so the moment of inertia for the composite disk, which is the given problem, will be I of the solid disk I1 minus I2. Okay, so I1 is now for the solid disk we have this formula. So m1 r square by 2 minus m2 small r square by 2. Now how do I find m1 m2? Now that is the question. How do I find m1 and m2? Now total mass is m, okay, and we know that if it's a uniform disk, so density has to be constant. So your density is mass by area, which is for the composite, its area is pi r square minus small r square. This is the area of cross section into thickness, which is unit thickness. Now the density is same whether I write it the density for this, or for this. Now density for this would be m1 by area, which is pi r square into thickness is t1. Okay, and the same density, the value is same because material is same, so density has to be same. So the same thing I can write it for the other disk, which is m2 by pi small r square t. So in this way I can relate m1. So m1 is m r square by capital R square minus small square, and from 1 and 3 I get m2, which is small r square m by capital R square minus r square. Now these two together, if I substitute in this, I will get the moment of inertia of the composite disk. So half m1 is capital M r square by r square minus r square to capital R square, minus m2 is m r square by r square minus r square and small r square. So now this thing, let's see what I get. So half m, because this m is the mass of the composite disk, don't confuse, because this mass will be different than this mass. Okay, so what I get is r power 4 by r square minus small r square minus r power 4 by r square minus small r square So this will become half m. This is r power 4 minus r power 4 by r square minus r square, and this comes out to be, so this a square minus b square in the numerator I can write as a square plus b square into a square minus b square, and in the denominator I have a similar term. So this will become half m r square plus r square. So let's look at the option. Option is T. So this is the mass moment of inertia of a composite disk. So any composite body, I can just visualize it as a Boolean operation of two bodies or regular bodies. That is what I know, the mass moment of inertia of a solid disk. So I can just view this hollow disk, the composite disk, as one big disk of radius r minus one small a disk of radius smaller, and I know individual moment of inertia. It's all basically mass calculations. Thank you.